Melanie Acosta. I'm a Science Program Associate at OceanX.
And I'm Jarala Kamal-Wang, a research analyst on the science team at OceanX.
Today we're here at Piermont Pier in Piermont, New York on the Hudson River. We've been in a drought lately, so we've been trying to understand what's been happening with water quality in the Hudson, specifically looking at salinity and temperature. Today, in order to look at the water quality of the Hudson River, we have to use a probe just like this to determine the salinity and temperature. So we're going to make sure that the probe is fully submerged and wait for the YSI to give us a reading about salinity in parts per thousand, or PPT, and temperature in Celsius.
And it's looking like the salinity is about 11 parts per thousand today, and the temperature is about 60 degrees Fahrenheit.
Because we've been in a drought, it's a little bit more salty than it would be otherwise. We typically have a lot more fresh water coming down from the north, which would make the salinity a little bit lower, closer to 5 to 10, but we have a lot more salt water than we typically do here in this part of the Hudson. We are now looking at salinity in another way. So I'm taking a little bulb pipette of Hudson River water, and we're going to put about a milliliter on the lens of the refractometer, and we're going to put down the lid in order to capture the water there and look towards the sun. So on this refractometer, I can see a bunch of different numbers that show salinity in parts per thousand. So here we're seeing that the salinity is 11 parts per thousand, which is definitely more saline than it's been in the past. Salinity is really important in understanding what lives in the water and why things live in certain places.
All right, now that we finished our water quality testing, we know the temperature and the salinity of Piermont Pier.
This is real science.
Now we're going to do a SaneNet demonstration. I'm here with Outreach Education Coordinator, Marissa. SaneNet is very useful for understanding a little bit about the biodiversity in the waters here. So we'll kind of be dragging this net out and kind of scooping up all the fish and seeing how the species composition might relate to the water quality that we have just collected.
Seining is actually an indigenous fishing practice. It's been used on rivers like the Hudson for a very long time. And we like to say it's a tried and true method to catch fish and crabs and other wildlife. A seine net is a large net that's connected on either ends to dowels. They could be wooden dowels like ours or metal. And it's a large net that has floats on the top to help hold the net up in the water column. And it has little weights on the bottom to hold the net against the river's bottom that you can catch those benthic critters that you want to catch. There's a little bit of a technique to seining. You basically need to make a little scoop with your net. So your pole should always be tilted back at a 45-degree angle away from the direction you're going. So if we're pulling our net in this direction, we want our poles tilted back in this direction. You want to have one hand high up, one hand a little bit further down, and then you just walk and drag your net. We're going to go out into the water and pull up on this beach and look to see what types of fish and crabs we might catch.
So we tend to catch a lot of Atlantic silversides over here. I've caught some bluefish, which are a more marine predatory fish over here. I've caught blue crabs over here, menhaden. I've actually caught a good diversity of fish. These are ctenophores, so they're not true jellyfish. They look a little more like blobs when we pull them out. And these more shapely jellies are moon jellies. They are true jellyfish, and at this stage of their life, they don't have stinging cells, so you can hold them and they don't hurt you.
Y'all gonna swim now? All right. That's all right. So a lot of the Hudson River or Jamaica Bay or whatever water quality data that you're looking at is just a whole bunch of numbers that tell you about the salinity and the temperature and the dissolved oxygen in the water over time. This changes with the seasons, it changes with the tides, and it's really important to understand how we're getting these water samples and what they mean. So we take water samples by hand, but also we use equipment that is run by the USGS and NOAA to understand how rivers are changing over time and over spatial ranges as well. So this is just a really single demonstration, kind of a snapshot of the river and what that means for the silversides that are living here. and what that means for us zooming out on a larger scale. So I'm gonna go into the water a little bit so that I can get away from some of the sediment near shore to take a water sample. So I have a clean bottle here. Whenever we take a water sample, we have to make sure to rinse out the bottle a few times in case there's any soap debris or anything else that could mess up the readings. So we start out by putting the water just underneath the surface, or the bottle just underneath the surface. Fill it up a little bit, put on the cap, and rinse it out 3 times. So 1, 2, and we like to make sure that we're wearing gloves because we have a lot of different kinds of nutrients and proteins on our hands that can get transferred to our samples. And we want to make sure that we're getting as accurate of a sample as we can. So that's also why we're rinsing out the bottle so many times. Okay, so now that we've rinsed out the bottle 3 times, we're ready to take our sample. We will start filling up our bottle. So this data can be used for lots of different things to understand the biology, the chemistry, the individual chemical compositions of the silver slides themselves. Putting together samples that are taken at different points in the river help us to understand how the river changes as water moves from the ocean up north towards rivers. So here we have a nice river sample. I'm seeing some cool stuff in there. We'll take this back to shore so that we can start analyzing the water chemistry within it. We can also subsample this big bottle into smaller silicone tubes that we can label with the time and date so we can freeze them for later analysis to look at nutrients, to specifically look at nitrogen and phosphorus, which is the basis for the ecosystem, and it helps everything survive. And we can also filter it down to understand both the particulate and dissolved components. So if we're gonna freeze this sample, we would have 40 mils here, which gives us just enough headspace to freeze the sample to analyze it later. And you can also make sure that there is nothing crazy in there that would make your analyses a little bit different, such as a little fish. So we just want to make sure if we're looking at the water chemistry, that it's just the water in these sample bottles. So this is the sample of the Hudson River water from today at 2:44.